about coming back to this issue of refactoring, coming back to this issue of Thursday's assignment as an example of refactoring. Ladies and gentlemen, I mentioned last time that the motivation for this class lies in many ways in the desire to provide students who are likely going to go out and need to serve to offer skills of professional software development, either as full-time software engineers, software developers, or as folks that will sometimes undertake software development for their organizations. And that's sort of the general goal, to prepare students well for that. And as such, the material in this course is designed to complement material seen in other courses where I think there are gaps and where I think there are issues. And a lot of it, again, is motivated by the fact that I used to see a lot of students coming to fourth year with what I considered important gaps within their understanding of software engineering, software development processes, yes, that's the domain of 371, but also in terms of their understanding of what it means to produce quality code. And also with the limited appreciation for the different paradigms, programming paradigms out there. Functional programming as being an example, aspect-oriented being another, declarative, etc. So there's a number of types of concerns that struck me when I saw students code. And it's something I feel viscerally. It's a good thing to develop as software engineers a sense of quality, and actually a sense of shame, a sense of when you're falling short of the potential for what you could offer in terms of the quality of the code, whether it's measured in terms of extensibility, clarity, etc. It's good to have an aesthetic sense which you aspire to. And when I think about that, and I think about my life as a professional software engineer, whether it's the small companies I'm involved in now, or whether it's as a software engineer for larger firms, the needs for students vary from low-level issues, from issues having to do with basic hygiene in code, putting out code that at a local level is understandable, is elegant, even beautiful. It's clear. It involves not a lot of extra cruft or complications. It is to the point. It is readable, concise, expressive, and general enough to address possible changes needed down the road. This sort of low-level code quality is an important thing that a lot of students lack. And I have been shocked many a time from students in our program, and yes, from people elsewhere, for the quality of code. And at the same time, in my professional life, I have seen some of the most exquisite code. And that code has been a standard to which I think myself, others can aspire. And if you look in today's industry, some of the people that I know that produce just the most beautiful code, the most elegant code, are now in positions of great authority because they have a clarity of thinking behind it, a clarity, a sense of wanting to deliver quality. So this first exercise, this refactoring, is nothing fancy. We're going to see the power of functional abstraction in a more fulsome way in coming weeks. We're going to look at higher order functions. We're going to see the ways in which they allow us to capture logic of great generality. But for this first exercise, what I am talking about is quite low-level refactoring. Now, if we look at code and we judge, a couple pages of code, which is what I've given you, maybe a page or two, and we look at it and we say, oh, that's ugly code. What sort of things might we be concerned about? What things might stand out? For those who are in 371, what things really got my goat in 371?
more just like static numbers?
Okay, yeah. What we call, they're called manifest constants. They used to be called Hollerith constants due to early Fortran work, where incidentally you could redefine pi. But manifest constants. So if we litter our code with manifest constants, we have 50 here, we have 49 here, we have 99 there, 100 there. That's a sign of some missing links. Why is that a problem? We talked about it a bit last time, but just to refresh our memories. Why is that an issue?
There's no semantic meaning of the number.
Yeah, there's no semantics captured. The fact that this one's twice that one minus one, or you know, this one is this other one plus one. That actually there's two 50s. One is for the width of the array, and one is for the height of the array, and one might modify without wanting to modify the other. There's no dependencies or logical connections captured. And that's a big issue if you want to modify the code. So much of our work as software engineers is about insulating ourselves from change. And you may say, well, what is that about? Well, what it's about is that one of the ways that we capture value in today's market is by being able to move nimbly, being able to respond to new market conditions, new technologies, competitors, to be able to respond to clients who request new functionality in a quick fashion. And in order to do that, we need our code to support that nimbleness, that ability to change quickly. And one of the key needs there is providing the clarity about what depends on what, so when we go to change something, we can see all the things that need to be changed along with it. And hopefully, so that we can change it in one place. In one place, not 10. If you think about it, there's a lot of risks there. Someone asks you, change, we talked about it last time. Okay, suppose screen width, window width, window height, 500, and they want you to support larger monitors, 1,000 by 500. Fair enough. So you go in and you search for 500 in your code. You find all these 500s. You don't know which of them is width, which is height, and you replace the 500s you think are right. There's potential bugs there, right? And then you find that actually things are all broken. It's all screwed up, and you spend another bunch of hours trying to find it. And you find there's actually all these 499s in there, which are conceptually, are at a logical level 500 minus 1, but you didn't find them when you searched for them because they're not 500. They're some other. They could be twice 500. You didn't find it. So it makes a lot of sense to have named variables, define them once, and then use them in a lot of places to allow us to change things quickly. What's another thing we might look for in code that would be of quality concern, that would make it ugly? Yeah?
Repeated code blocks that could probably be salvaged by making like a call to a function.
Yes, repeated code blocks. They're kind of a cancer that you see in the code, where you see this kind of this metastasis of this code that logically is one thought, one concept, one concern, and it ends up appearing in lots of places in your code. And the risk there is, and you referred to it, Warren, the risk there is that you have to change things many places if you have to update it. So okay, we're switching over to a new security scheme for our software, and now every place that code block appears, we have to go down and find it and trace it. You may think that's an easy thing, but today's world, for technologies we'll be talking about later in the semester, things like reflection, for example, you may search with your nice little search engine, whether it's grep or the Eclipse search or whatever, and you can search for code and sometimes not find it because that code is dynamically loaded, because it is depending on it has dependencies which are only encoded in a configuration file when you have an inversion of control type situation. So this notion that we're going to be able to really easily find all these cases of duplicated code is often problematic. But even when we do find them, it takes us extra time. We may miss some. We miss some. Someone's working on that part of the code. We change it in the other part of the code base. They push their components back, and suddenly that code has reappeared, and we didn't get a chance to update it, or our updates were overwritten due to a merge conflict. Okay. So repeated code is one of the big things I look for, and it's often one of the signs of a failure to abstract, a failure to capture something in a general way. So that's one of the big things I'm looking for you to clean up. How about other things?
Indentation.
Yeah, indentation. Oh man. And you may think this is second nature, and if so, I hope it is for you. I hope for 95% of the people in the room, I hope that it is second nature. And I hope it will be second nature in the after a few weeks for everyone. Indentation is one of these key things that we, as software engineers, we depend on intuitively after a while. We glance at code and we think we can see the logical structure by looking at the indentation. And where that's violated, our quick glances are misleading. We see something, we see an if statement and something indented under it, and we immediately think, oh, okay, that code under it only takes place if the condition is true. And it turns out, well, we didn't catch the fact that there was a line right next to that if that had the thing within the if next to it instead of below it, and the thing below it is always executed. That's how bugs creep in really easily, or more to the point, that's how bugs are missed when we're trying to debug code. We don't see that. Or if we're trying to modify it, bugs get introduced. So indentation is key. And you may think it's obvious. Well, it's not obvious to some software engineers out there. I remember a memorable case within the past 2 years. This is not, back in the day where we were using stone tools. And I had a student who showed me code that exhibited pathologies equally as bad as what I've given you with this code in terms of indentation. It almost freaked me out. Gave me the heebie-jeebies, at least. And maybe the willies. It was really ugly. It wasn't like there was no thought behind it. It was thought that flies in the face of our conventions. And that's just it. There's no inherent privilege to our conventions of indenting, but they are time-honored conventions that have been built up over decades. And it's important to adhere to those conventions because software engineers around the world count on them. His code was very interesting. So he would have declarations of successive variables. So maybe in C code or Java code, you have successive local variables declared line after line. Whenever he had that, he would indent each one more than the last. So it would be a sort of big diagonal. And it was certainly distinctive. I mean, there was a certain aesthetics to it, but it really threw me off. What bothered me more was that the logical structure was not captured. The fact that all the loops and if statements and so on would all be at the same level of indentation or something. So you couldn't glance it and see the nesting, what's inside of what logically. And that matters. That really matters when we're trying to understand the code. We as software engineers are often under time pressure. And it matters a lot that we can glance the code and have an understanding of what's there and what's not there. Okay? So that's another big thing I'd like you to clean up in that code. What are other things? What are other things that might confuse us? Yeah?
There was commented out code, and there also wasn't any comments explaining the code.
Yeah, exactly. Okay. Code commented out. It's kind of the tombstone of code. It's just kind of littered in there. You don't know, why is it still there? Is there some uncertainty about whether the current code works and this might have to be put in? What did this code do? It distracts you from the real code. And then, if you have code that is there with no comments, that's a big issue. I will tell you, and you'll see it expressed here in town for some of the software engineering firms, comments are really valuable, but really clean code can almost make the comments within the code less needed. Why is that? Why is that? I mean, when I say less needed, it should be stronger than that. Can almost make it unneeded. That's what you'll hear from some firms. That you don't really need a lot of inline comments if the code is really clean. What could really clean your code up to that point?
Self-documented variable names.
Self-documented variable names are key. Variable names that give the intention behind the variable. They communicate what this variable is for, what it means, how it's to be used. And there are religious wars over this, or ideological wars, I guess I should say. There are wars over, they reach sort of religion sort of an intensity and fervency of belief sometimes. And I don't have a dog in that fight as to which is the best system. So you'll find folks in the Microsoft camp arguing, at least in earlier years, for Hungarian notation. Others will argue for a type of naming convention you'll see within Java a lot, which has its own conventions. Others hark back to the C era and some conventions there. But the point is, have a convention and use variable names that at least connote something about what the uses of the variable, what its meaning is. So it's not A, B, C, or X, Y, Z. It's something that's clearer about how it functions in the program. Some people will encode something about the type. Some people will encode something about the sort of semantic category. So is it a count, for example, or a density? Some people encode units. If this is code capturing features of the world, they'll encode something about the unit. So this is a daily value versus this is a weekly value. All those are good things. And the point is they're good because they can lend extra clarity to the person who's looking at the code. And when you have that, and when you have accompanying names for functions or classes, you start to see a logic to it that's almost self-documenting. But there is, ladies and gentlemen, one place where these comments are absolutely essential, and where self-documentation argument falls apart.
Function header?
Yes, function headers. But more function headers as an example of it. It's really about contracts associated with abstractions. Sometimes those are for functions, methods in a function, for example. But sometimes they are for classes as a whole, or aspects, okay? It's basically where we have different subcomponents of the program, and there's a contract for the use of it, things that it expects to do its job. It needs these things in place, and certain things, if it does its job, that are guaranteed. And often there's other information, like for classes, as we will be talking about extensively later in the course, each of these things. We're going to be talking about, for classes, additional specification of invariance and history properties. Okay, it's an important area of learning for stateful data structures, and even for immutable ones. So, what I'm looking to you to provide for Thursday is, in a span of no more than an hour or two, for you to clean up a code according to some of the principles I've just described. Now, I'm not going to ask you for Thursday to put in place all the mechanisms for the function headers and the contracts, okay? You are welcome to do that, but that's really going to be emphasized more in coming lectures. If you do that now, I think it'll be great. It wouldn't hurt to try your hand in it, but I don't want you to spend, like all these take-home exercises, I don't want you to spend hours and hours and hours doing that. So at least try the low-hanging fruit in terms of cleaning the basic code up. And I'm asking you to go through this exercise not as a torture, but there will be parts of it where you will notice, you will experience pain. You will experience displeasure. You may experience distress. And hopefully you will experience aesthetic aesthetic shock. As well you should. But the experience of trying to clean up code like this is one that's familiar to many practicing software engineers. And it is a memorable experience. Hopefully it will be an enjoyable experience, kind of like, coming to a room you haven't visited in a while and cleaning out the cobwebs and spiffying it up, and really making it a habitable place, okay? I'm looking for you to make that code habitable, okay? And I will tell you, though, that all those things in the code, I've readily seen code around. Yes, I deliberately put in these things in the code, but I did them with a model because I've seen them before a lot, and I want you to go through that experience. Okay? That's for Thursday. Some comments on refactoring. Refactoring, this reworking of code so that we don't change its function, we don't change what it does, but we change the quality with which it accomplishes it, how it does it. That's one of the most important skills one important processes that we can bring to software development. And indeed, you'll find firms in town and firms around the world who basically use agile processes, such incidentally as we'll be using in 371 for those in this term. But every few iterations, they pause in the sense of they'll have a sprint, 2-week sprint or 1-week sprint. But the goal of that sprint will be refactoring. They'll take the code that's come up and they'll rework it to be more sustainable, more structurally sound, more understandable, more extensible, more general, and yes, more beautiful. Okay? So in software projects, often there is a conscious attempt to take time and devote it to this refactoring. And I'm going to ask you to do that for Thursday. Okay?
So
Yes.
should we submit our
Yes.
draft one
Yes.
before the class begins?
Yes, exactly. So you'll notice that the due date associated with the exploratory topic 1 coincides with the beginning of lecture on Thursday.
So how many files do we need to submit? Just one. The one we refactored. The code.
One file, one refactored bit of code. And again, you're going to be marked on this, not on is your code the most beautiful or whose code is the best. I'm gonna look at them, but I won't have time to look at them before class because you're handing them in for class. I have it due at class because I'm going to show you some code that I think is a step forward. I'll show it to you in class, and that's why it's the cutoff. So, get it in before class. If it's not done, fine. I understand it. It could take a while, but put some honest effort into it, and that's what you'll be marked pass fail on. Is did you really engage with it? Did you try something? Okay. I don't want you to spend hours and hours and hours making the most pristine code. Although I always love beauty. So I will take a look at the code you handed in, but it will be after class, and then I will comment on it. Okay. So that's a comment on Thursday. Today we're going to talk some about functional abstraction. We're going to talk about putting in place this structure, put in place these boundaries, put in place these components, these pieces of a program with well-defined contracts. And we're going to reflect on some of the whys of that. And hopefully this will give us a chance for understanding on Thursday some of the importance of you undertaking your refactoring of the code. Okay, so one thing you'll find for the code on Thursday is that basically it's a C function with a god-awful big function. It's, dozens and dozens, if not, 100, 200 lines associated with it. Why is that an issue? Why is that a concern? Why is that a problem?
It's hard to
Yeah, it's hard to understand. Why is it